The sun is breaking the universe's rules, and you're about to find out how. Picture this, a massive, fiery ball of gas, tirelessly blazing for billions of years. It's the ultimate fusion reactor, right at the heart of our solar system, keeping us warm and alive. But here's the kicker. According to the universe's own rulebook, the sun shouldn't even work. Yep, you heard that right. Classical physics suggests this cosmic furnace should be as lifeless as a burnt-out light bulb. So, how does the sun defy these odds? Let's dive into the basics of nuclear fusion, the process that powers the sun. Imagine hydrogen atoms, tiny building blocks of the universe, coming together in a cosmic dance to form helium. It's like a grand cosmic chemistry experiment, releasing energy that lights up our skies. But there's a catch. These hydrogen atoms are positively charged. And, just like trying to push two magnets together with the same poles facing, they repel each other fiercely. Now, here's where things get intriguing. You might be wondering, how does the sun keep shining against these odds? How do these stubborn hydrogen atoms overcome their aversion to cozying up? This is where the paradox deepens. According to classical physics, the sun's core isn't hot enough to force these atoms to fuse. It's like trying to start a roaring campfire with just a faint flicker of a match. Frustrating, right? But what if there's a cheat code in the universe's programming? A cosmic loophole that lets the impossible happen? Enter the mysterious realm of quantum mechanics, where the usual rules take a back seat. In this subatomic world, particles don't behave like neat little billiard balls. Instead, they act like waves of probability, existing in multiple places at once, even where they shouldn't be. Imagine this. When two hydrogen atoms in the sun get close enough, there's a minuscule chance, an almost laughable possibility, that one can tunnel through the repulsion barrier and fuse with the other. It's akin to watching someone walk straight through a solid wall and casually waving from the other side. It's mind-bending, but it's also what keeps our sun burning brightly. So, how often does this incredible quantum tunneling occur? For any given pair of atoms, the odds are insanely small. But remember, the sun is not dealing with just a few atoms. It's got a mind-boggling number of them, around 1057 to be precise. So, even if only a tiny fraction of these atoms manage to tunnel and fuse every second, it's more than enough to keep our planet bathed in light and warmth. This quantum tunneling trick doesn't just keep the lights on. It's a cornerstone of our existence. Without it, the sun wouldn't shine, and life as we know it wouldn't exist. It's a humbling reminder that our reality isn't just a rigid set of rules. Instead, it dances on the edge of probability, where the improbable becomes possible every single day. But here's an exciting twist. Quantum tunneling isn't just a stellar phenomenon. It's happening everywhere, even in the technology we use daily. Think about it. Every time you unlock your phone, you're witnessing the magic of quantum tunneling in action. Electrons are tunneling through barriers like nimble, subatomic ninjas, making your tech work seamlessly. So, next time you glance at the sun, not directly, of course, remember this. The light warming your face is the result of trillions of these impossible events happening every second. The sun shouldn't exist, but thanks to quantum tunneling, it does. And that means you do, too. If this journey through the sun's impossible secret has sparked your curiosity or made you question everything you learned in physics class, hit that like button, subscribe, and share this video with your fellow space enthusiasts. Because here at Nerdy Nonsense, we explore the quirkiest corners of the cosmos, where even the impossible finds a loophole in reality. Alright, let's dive into the mind-blowing world of quantum mechanics, where the rules of reality take a wild, unexpected turn. Imagine for a moment you're at a party. Everything's going as expected, people chatting, music playing. But then, someone walks straight through a locked door, casually waving as they pass through solid wood like it's nothing. Sounds like a scene straight out of a sci-fi movie, right? Welcome to the bizarre reality of quantum tunneling. You see, in the quantum realm, particles don't just sit tight in one place. They're more like a blur of possibilities, existing in multiple places at once. Imagine them as tiny ghosts, slipping through walls you'd swear were impenetrable. This isn't just a quirky idea. It's how nature fundamentally works at the smallest scales. Now, let's talk about the real magic trick, quantum tunneling. Picture it as watching someone walk through a locked door without a key. It's not supposed to happen, yet in the world of quantum mechanics, it does. Here's the kicker. These particles can sometimes pass right through barriers they're not supposed to cross. It's like they've got a backstage pass to reality's VIP section. But how often does this sci-fi scenario actually play out? Well, the odds are astoundingly low for any single particle. But here's where things get really interesting. The sun, our giant ball of fire, is packed with atoms. We're talking about 1057 of them. That's a number so huge, it makes your head spin. Even if a minuscule fraction of these atoms manage to tunnel and fuse every second, you get something extraordinary, the warmth and light that fills our solar system. This brings us to an intriguing realization. The universe doesn't operate on perfection. It's all about probability. And when you've got a cosmic furnace like the sun, playing the odds isn't just a game. It's how the universe keeps the lights on. So, what does all this mean for you and the universe? Well, without quantum tunneling, the sun wouldn't shine. No sun, no life. And no life means you wouldn't be here, questioning your high school physics teacher's sanity on a random Tuesday evening. It's a humbling reminder that the universe is a tapestry of maybes, where the improbable becomes the everyday reality. In the grand scheme of things, you're living proof of quantum mechanics in action. This mind-bending process doesn't just fuel the stars, it fuels life. So next time you feel the sun's warmth, remember that you're basking in the glow of a trillion quantum miracles. And isn't that something worth marveling at? Imagine waking up without the sun to greet you. Without its warmth, Earth would be a cold, barren rock. But here we are, basking in its glow, all thanks to quantum tunneling, the universe's lucky break. It's the cosmic hack that keeps our star burning and, by extension, keeps life on Earth thriving. Without it, you wouldn't be watching this video right now. Seriously, we owe our very existence to this quantum quirk. Now, let's shift gears a bit. Quantum tunneling isn't just a star-studded phenomenon. Nope, it's happening all around you, every day. Think about your smartphone. It's powered by tiny quantum ninjas, electrons that tunnel through microscopic barriers, making your tech magic possible. It's like having an unseen army of particles working tirelessly, letting you swipe, tap, and text. Next time you use your phone, take a moment to appreciate the unseen quantum magic at play. But back to the sun, our cosmic rebel. It shines in defiance of classical physics, a testament to the universe's bizarre nature. Every ray of light is a reminder that the sun shouldn't exist according to the old rules. Yet, thanks to quantum tunneling, it does. And that means you do, too. How's that for a mind bender? If you've been amazed by the universe's quirky ways, hit that like button and subscribe to keep exploring the strange and wonderful. Share this with your friends who love a good cosmic mystery. Here at Nerdy Nonsense, we embrace the impossible, finding loopholes in reality that keep us guessing. So, what other rules do you think the universe might be bending? Drop your thoughts in the comments below. Let's keep the conversation going, because in this universe, anything is possible.